Kia ora koutou, ko Ngāti Irihae toku iwi no Kirikiriroa ahau, ko Doran toku whānau, ko Bridget toku ingoa. I'm Bridget and this is a lecture about transportation in New Zealand, some perspectives of mine having worked in the industry here for 20-something years. It's a lecture for undergraduate civil engineering students who haven't had much of an introduction to transport, perhaps beyond highways and surveying. So background to me, I have worked in Hamilton for the last 23 years since graduating as a civil engineer from the University of Canterbury. And since that time, I've worked on a range of different private consultancies. Started out on roading and appraisal of roading projects, passing lanes, road realignments, road safety. I got more interested in the human side of transport through my master's and then PhD, and in both of those I studied driver behaviour in a variety of ways and also transport policy, and while I was studying these things part-time, I was thinking constantly about how those insights applied to my work and to understanding how the profession works as a whole. So here we are. I'd like to acknowledge and point out that the Engineering New Zealand has a transportation group. Engineering New Zealand is the professional body that supports and regulates the engineering profession. The transportation group is a technical interest group of Engineering New Zealand, and it's the largest one that Engineering New Zealand has, over 1,000 members, and membership is free for students. So I would encourage anyone interested to sign up. You can go to the website to become a member and then receive information and newsletters and things to get more insight into transport, how it plays out as a career in Aotearoa. To start with, I'm just showing a few of my recent LinkedIn posts as just a taste of what's on my mind these days and the big picture, I guess. It's an interesting time in transport. We have got a government that is focused on economic productivity above all other things, and unashamedly so. That's fine. However, the way that that policy is being interpreted and flowing through to investment means that there's quite a roads and road expansion focus, which is not as balanced as some of us would like. So even 50 years ago, the national government acknowledged that, well, not just acknowledged, but advocated for improvements to public transport in cities because of their inherent value and the efficiency. If you're going to move a lot of people in a city, it doesn't make much sense to move them one car per person. So we've known for a long time, and politicians of all flavours have long advocated for an efficient urban mobility investment approach, which is as many people as possible walking, biking, using buses and trains, and that would leave the roads free for people who need to use them, which is a lot of tradespeople, ambulances, and people who otherwise don't have access to those other modes, some disabled people, for example. The other topic that's on my mind at the moment is the environmental crises that are facing the planet, and these are best framed up, as far as I've seen, in terms of planetary boundaries. This graphic was produced by the Stockholm Resilience Centre. You can Google planetary boundaries to learn more about that. What it's saying is that while climate change is a problem for us, it's not the only one, and potentially not even the worst problem facing humans. There was just another article in the Guardian News Online yesterday about the increasing awareness we have about plastics, their toxicity, especially in food packaging, but all around us, the extent that we're using plastics and other what we call novel entities is harming human health, reproductive health. It's everywhere, it's in our food. It's a huge problem that is not really directly related to greenhouse gas emissions at all. So the purpose of these planetary boundaries is to recognise that the main problem isn't just carbon emissions. The main problem is wealthy nations consuming without considering the overall effects of that consumption from the Earth's crust. What are we doing? Importing plastic stuff from China that we don't actually need. Where are the limits to this market-driven consumption? And how do we deal with the waste of those things? What does that mean for the planet? So planetary boundaries have me thinking about the land and the seas and the water and the rivers. Especially living in Kirikiriroa here, we have rivers and gully systems, and obviously the land, they're all connected, and the air and the groundwater goes through to those gullies and rivers. What are we putting into those things? How does that affect the health of the river that we draw our drinking water from? What are we doing to ourselves? So while there's international legal focus on climate change and greenhouse gas emissions, my approach to thinking about transport policy and investment is much broader than that. How much are we consuming? How can we mitigate and manage our consumption overall to sustainable levels? So with those things in mind, today I'm going to be talking about ecological overshoot, that's what I've just mentioned, planetary boundaries, and then go into how decisions are made in New Zealand now, different transport modes and why they're useful, and some policy objectives. So if you're interested in that ecological overshoot question, it's best explained by Bill Rees, who's one of the world's best thinkers on this topic. You can look up his talk. Another good person to follow is Nate Hagens, who has a podcast called The Great Simplification. He talks about a wide range of topics related to planetary boundaries, but going beyond that as well. So world energy system, economics, spirituality, how that fits into the mix, culture, why we are the way we are, basically, and what we might like to do about it. It's got hundreds of interviews available. And as I said, the fundamental problem with what we call overshoot is that we're taking resources from the earth faster than the earth can replenish them. Not just fossil fuels, all sorts of rare earth minerals, basically digging up the earth's crust faster than that crust is replaced. And then we're producing waste faster than the earth can safely absorb it, tipping all of those planetary systems out of balance. And that's a challenge when it comes to engineering thinking, because as a civil engineer, I know that we are trained to define our problem before we go any further. And oftentimes our problem looks like this. It's a two-dimensional representation of a beam, usually, or some kind of load-bearing thing. It has forces acting on it, on top, underneath. And then we draw this little cloud around it, or we used to when I was in the design office with my drawing tools. And that means we're not considering anything outside of that little system. When it comes to transport planning, that approach is very problematic, because transport doesn't exist by itself. People go from place to place for all sorts of different reasons, and they may be passing passing through an intersection or walking along a street, but it's always part of a journey. And that journey is sometimes an A to A journey. What I mean by that is we measure trips from A to B. We talk about the journey to work quite a lot, for example, or journeys to school, journeys to education. But if somebody wants to go for a walk, that is a journey from home to home often. And that kind of trip is not really valued and captured as well as it could be in transport policy and practice. We tend to look at the network and how the network is performing, and not so much at people's lives and whether they are getting places they need to go and making trips that are healthy for them. So one of the ways that this problem manifests is if we take a narrow focus and look only at climate change, then we might think we draw a bubble around the car is the problem, and the tailpipe is the problem of the car. How do we stop this car spewing greenhouse gases into the environment? Well, easy. We switch it to a battery. In New Zealand, we have a lot of hydropower, geothermal, wind and solar, people even having them in their homes. So you could have solar panels on your roof, charging your electric car, happy days. The problem with that approach is that it only looks at the carbon emissions part of the car fleet itself, the absence of a tailpipe. What it doesn't look at is the impact of what we call car-centric planning on the communities and environments that we're building for ourselves. And in Kirikiriroa, where we are, like everywhere in New Zealand, it's essentially a car-centric city because it's been developed that way over many decades. We have suburbia, we have long winding streets that it's difficult to put efficient bus routes on. We have nice and frequent bus services, for example, the Meteor, the Orbiter and the Comet, but they can't help everyone get everywhere because the city sprawls too much and we live too far apart from one another to make those frequent services effective everywhere. So we build more road lanes, we have urban sprawl, and all of that infrastructure requires concrete, asphalt, steel, plastics. And meanwhile, the cars are driving around and they're dropping bits of tyre all over the roads. Tyre particulates are a huge problem in our groundwater. They are part of the novel entities that get into our food through water and land. And that whole system generates its own carbon emissions simply through construction and maintenance of this network of roads. And those things contribute to the other planetary boundaries beyond climate change and greenhouse gases from the car itself. So while I think that electric cars are great for an individual, they make a lot of sense if you can afford one, as a transport policy investment approach, they have limits that are not often acknowledged. Whereas we have other tools in transport policy and planning that are readily available and do tick a lot more boxes. And one of the reasons I like promoting e-bikes in particular, some people will say, oh, but they're just minerals as well. They need to be dug up, and it's true. Why can't you just ride an analog bike around? E-bikes, I think, are a sensible transition vehicle to a lower consumption future because they weigh less than the person riding them. So the energy return on investment is much greater. My e-bike is a converted push bike. It weighs 19 kilograms. So that's a lot less than I weigh, whereas my car is a 1.5 ton hatchback. That's relatively small. We have a huge imbalance in terms of energy return on investment for the vehicles that are moving people around. And if you were looking to design cities from scratch, if you were starting a new civilization, you wouldn't design them around cars quite as much as we have ended up doing. They're also like a delusion because they're great to drive. I love my car, I love driving it, and it deludes us into thinking that we should be able to drive A to B. It's great, it's luxurious, and then we get stuck in a queue. Oh, this isn't fair, all of this other traffic. We are the traffic, and we're living the life that's been laid up to us, and it doesn't work once you have a lot of people living in a city, as literally every city in the world knows. So I'm going to talk now about transport in New Zealand, how it works, and some kind of technical stuff about transport modes. So as I've said, our government at the moment has this focus on economic productivity. The government of the day will prepare a government policy statement to list its objectives and to define how it seeks to achieve those through investment. We used to have inclusion and environmental sustainability as part of that policy statement. They're not there anymore, not at the moment. We have economic productivity and also some road safety. So what happens with those things is that we have people in different parts of the transport system making different kinds of decisions. So at the University of Waikato, for example, there is a lot of transport adjacent research that goes on in a lot of different fields that you might have had no idea that actually happens. My doctorate at Waikato was in psychology, and that was transport related. There are, of course, environmental planning people who talk about land use and transport integration, and then economics and law as well, with a range of funders, although the current climate for research funding, especially multidisciplinary like this, is not great at the moment. In any case, waka kotahi and local councils, regional and district and city councils support research in different ways. And the closer you get to the local community, the more applied that research would tend to be. So you're looking at the effectiveness of interventions quite directly. Policy is the next step from research. Policy is intended to be informed by evidence, and there are international policy groups that New Zealand is a part of. We have members on these forums. Then nationally, we have the Ministry of Transport, which supports the government policy statement and delivering it. But New Zealand Transport Agency is much, much bigger than the Ministry of Transport. Probably, I'm not sure exactly, maybe 5 times as many staff in the New Zealand Transport Agency as there are in the ministry. Maybe the number is greater. So you have policy staff in the ministry. You also have policy staff in the NZTA. NZTA has all of the parts of this circle in it, because it's so big. It has its own policy and methods to deliver on different objective areas. When I say objective areas, I mean your objective might be road safety, your objective might be economic productivity. Often a project will overlap those, but sometimes too we have specialists on each one of those things. Then at a regional council here in Kirikiriroa, we have Waikato Regional Council that is required to prepare regional land transport plan and public transport plan. So that means that for the districts from Coromandel and Waikato in the north down to Taupo, and there's 11 districts in the Waikato region as a whole, and the Waikato Regional Council brings all of those transport people together to provide input into the regional plan, depending on the regional objectives for transport and other things as well. So it's meant to be an integrated kind of approach. Then all of those councils will apply for funding subsidy from New Zealand Transport Agency to deliver on their regional and local objectives. When it comes to planning, which is a step below policy, policy is more about the vision and the ideals and where you'd like to go. Planning is how we're going to do that in terms of the rules that we have and the codes that we're going to ask people to use when they're actually designing streets or bits of infrastructure. And there are a raft of them. National standards that we refer to, some of them are international. We share a lot of our standards with Australia, particularly with transport. There's an organisation called Austroads, which keeps and maintains a suite of design guidance and codes and things. And then at a local level, there are district plans and specifications to help dictate what the construction requirements are out on the street. So engineers and others will take the plans from the council. They'll say, we want to upgrade this intersection from a priority control, so it might be a give way line only. We're going to put in traffic signals, or we're going to put in a roundabout, or we're just going to change the curbs or something. And then the engineers will take that and they'll design it, they'll check it with models to make sure traffic can negotiate that new layout. They will design the signal phasing if it's traffic lights with computer models to say, well, what are the different traffic movements now? What would they be if we put this kind of signal phasing in? What about if we gave the green arrow 20 seconds longer? What would that do to the queues in different directions? And there are computer models that can tell us with pretty good accuracy at that level what you're likely to get in terms of flows and delays and things. During that phase, we sometimes do public engagement. It depends a lot on the kind of project that it is and how much engagement there's been before. And then we have contractors and a lot of engineers working with them to actually build the things. There's a supervising engineer from the road controlling authority. Sometimes they appoint one from a consultant to do that job for them, and project managers to make sure that it's all running on time, on track, and to manage any emerging issues, because every construction project has emerging issues that you didn't know about when you were drawing up the plans. Then we monitor, and ideally we'll go back and check every design that we've built to see whether it's meeting our objectives. Why did we do this thing in the first place? And is it achieving our goals? So short term, we have a lot of traffic operations centres. For example, in Kirikiriroa, we have some security cameras on some intersections to look at any emerging incidents. The biggest ones tend to be on motorway networks. Auckland Motorway has an operations centre like this, almost like air traffic control, where they're sitting and actually looking in real time what's going on in the motorways. Once someone from there told me that they have some kind of incident on the Auckland Motorway network every 20 seconds. So that could be a crash. It could be somebody's hit a animal or something on the road and caused the queue. It could be that a child has dropped a teddy bear out of the car and the parent has panicked and braked. Any kind of incident, they will look at it and decide whether they need to do anything about it. For example, send out temporary traffic management or emergency services if it's more serious. So they're looking at that in real time. But in terms of that monitoring of the bigger picture, did this investment achieve its goal? That doesn't happen as often as you might think. In fact, it's quite rare to go back and check whether a new road or bus route or pedestrian crossing actually delivered the benefits that we were seeking, partly because it's quite complex. There's a lot of other stuff going on that we can't easily incorporate into that monitoring. Nevertheless, more of it should probably happen than does. So when we talk about transport modes, that means how are people getting where they want to go? And we measure that in a few different ways. One of the main ways is the Ministry of Transport runs an annual, well, it's actually ongoing household travel survey. When I say ongoing, they're surveying people every month and building up this continuous database of trip choices that people are making. And people are given access to a digital survey. I think sometimes they can even have it on their phone, so it automatically tracks, once you've signed into it and accepted this deal, it tracks your transport for a week, and then you can just code each trip in terms of what mode you were using. So it would know that you were traveling about the speed of a car. Did you travel by car? Yes. Were you a driver or a passenger? So from those surveys, we have a pretty good idea of the overall mode share of travel in New Zealand. And as you can see there, like I've said, we have very car-centric places. So most people travel by car most of the time. 70, 80% either as a car or van driver or passenger. And then walking is a lot. Walking is about 13%. The household travel survey doesn't include walking for recreation, whereas there are other surveys that do. For example, Sport and Recreation New Zealand have an annual survey, and walking is consistently the number one recreation exercise for every demographic group in the country. It's the most common thing that people do for exercise is to go for a walk. So that's important to bear in mind when we're planning walking routes around cities as well. We also have a network view of what is happening on streets. So the household travel survey is a person-centric view. What are people doing? But we also need to know about how much traffic is there out there so that we can plan maintenance activities, for example. We can plan for growth. We can look at road safety in terms of, well, where are the crashes occurring? Where are the crashes occurring where you wouldn't expect them to? So in other words, where are crashes overrepresented in terms of miles travelled? So you can look up all of this information online these days once you have access to the system as a transport engineer, and find out the traffic volume on any street in the country pretty much. And there's a website and it will give you the annual daily traffic, annual average daily traffic, which is what AADT stands for. So most kind of streets, so there's an example there that I've got on that slide, State Highway 26. So that's the bit out towards Morrinsville, the road to Morrinsville, but it's in the kind of close to the Hamilton urban boundary. It's saying that there's roughly 5,000 to 6,000 vehicles per day, but that was a long time ago, so it's probably up to 7,000 or 8,000 now. And then the expressway would have affected that, right? That map was pre-expressway. Gosh, I don't remember when I did that snip, but these tools are evolving all the time. Now, there's a reason that I said before the most efficient way to move people around cities is not necessarily to build more roads. This is a snip of the Auckland motorway, Southern Motorway, but it could be any motorway in the world. The challenge with transport engineering is that there is such a big demand for people to drive because it feels like such a premium way to travel. People will do that if they can get away with it. So if we have a congestion problem on a motorway and we add another road lane, that just means more people who avoided it before will use it now. Yay, there's more space, I will make that trip. Or I'll make that trip at a more convenient time than I was, because they might have been, going to Auckland on a Sunday morning because it's much, much easier than going to Auckland on a Monday morning. So this is called induced demand. If we expand a road, everything else being equal, the congestion will return to what it was like within, months or years of that new capacity being added. Because it's a dynamic system and people have changed their mode and their trip choice based on their understanding of how that congestion is. If we add capacity, they change it back, and you get no net benefit in terms of congestion. You just get a lot more people traveling very slowly than you did before. And most of these people in these vehicles will be one driver and 0 passengers. We know the average occupancy of a car in New Zealand is about 1.1. So in other words, 9 out of 10 have one person in them and the 10th has 2. It is a very, very inefficient way to move people around cities. Now, here's a movie that I'm going to show you, and hopefully the sound works for you. What you're looking at now is a typical traffic flow. Sector. Materials. Pretty impressive. So we've taken your project. Road upgrade, extra lanes, modern off-ramp lane. We've factored in all those improvements. So starting with current flow during peak, then during construction, some problems. And when it opens, it's pretty. Machine learning, we can keep it going. Great. Where'd the green go? Why? Have you heard of the Jevons paradox? It basically states that the better you make something like a road, the more people will use it. Isn't that a good thing? No, it means you spend a lot of money for a very short-term benefit. So there is some benefit. Oh, sure. Average travel times crossing the city will be cut by 2.5 minutes. Or a little less. Call it 2. And that lasts for 15 minutes. Then declines. No. Stays flat. Then declines. Well, for $300 billion, I guess we were hoping for something a little more dramatic. 2.5 minutes. Call it 2. You don't look happy. Hopefully that worked for you. If not, you can look up Induced Demand Utopia. It's from an Australian TV show, very popular transport engineering video. So what it's saying is that it's just not a useful thing to do to provide more and more road space if your goal is economic productivity, for example, moving a lot of people around a city, connecting freight to where it needs to go, helping people to get to work, etc. Cars are a very inefficient way to do that. In fact, the best thing we can do for people who need to drive is get as many people out of cars as possible. So next year is quite an exciting time for transport in New Zealand, because the Auckland City Rail link is opening. I should have put a slide on about that, but the big advantage of it is not just that there are 3 new stations in Auckland city centre, it's that the line moves from a dead end into Britomart into a loop, which effectively doubles the capacity of trains in the whole Auckland network. So that means that there's going to be a lot more scope for reliable and frequent train services around the whole city, as well as these new stations, creating more vibrancy and access in the city centre itself. So hopefully that triggers a big shift in public perception and understanding of just how useful it is to have a modern public transport system. Hopefully also it means that we'll have a more frequent Te Huia train service between Kirikiriroa and Auckland. As I said, the problem is that it's fun driving a car. I like it, and we delude people into thinking that we can have that for everybody, whereas space is constrained and it just doesn't work that much. So what can we do instead? Well, in Oniwa Road in Auckland, for example, there is a T3 lane, which means buses and any vehicle carrying 3 or more passengers can use it. Motorbikes can use it as well. And during the peak hour, 54% of people are carried by 6% of vehicles, buses in that route. And people use the buses because they're a lot quicker in that situation than cars. You can fit a lot more people in a bus than you can in a car, but it doesn't necessarily look like that when we're out driving and don't see them so often. So as I said, policy is about the vision of transport. Anytime that a government organisation publishes a vision, it talks about some aspect of flourishing or well-being. Recently, our government removed the requirement for councils to consider well-being in their policies, but it doesn't mean they're stopping, because if you're not considering well-being, what are you doing? There's also a growing awareness of the links between stress, mental health, and productivity, including economic productivity. 7 years ago, I was at a conference in Wellington about well-being for public policy. It wasn't a conference for transport people. I am certain I was the only transport professional in a room of a couple of hundred. Mostly they were academics and general policy people. But this visiting psychologist said that the number one way to improve quality of life is to invest in mental health services. The number two way is to promote mixed use zoning. So that is the opposite of what I've called car-centric suburbia. We have in the central city in Hamilton a few examples of mixed use developments where there's an apartment building, and then on the ground floor there's shops and local services, dairies, dry cleaners, gyms, any kind of retail. And what that means is people live and work and play all in the same place. And when you've been overseas, if you've been to big cities overseas, the most vibrant cities are those where there is this density of use and mixed use, so that there's a lot of interaction going on at the same time. When I travel to Australia, I like to rent an apartment in the city for exactly that reason. You get out the door and you're in the retail and foodie zone, and it's just a great way to get around. You don't have to drive places or worry about parking. So if we're going to transition to a kind of future where we have more well-being in our cities, we have better outcomes in terms of transport network efficiency, we might need to change some of the data that we use. We use a lot of, like I say, network-based data about traffic volumes and traffic composition. In other words, how many trucks there are versus cars. If we even think about a city, like Hamilton City, the way that we even think about it is a road map. If you look up a map of a city, it's a road map, and that is so normal to us. You might be like, why is she saying that? Well, it's actually a bit strange when you think about it. We don't have a conception of the catchments in our city necessarily, where the rivers are, where the hills and mountains are. We think about places in terms of roads because that is the way that we have been kind of conditioned to live. We need to get places by car, so we look up road maps. That becomes normal for us to how we see the city. It doesn't have to be that way. For example, we could use information about who doesn't have access to a car. This would be more of an equity lens on transport, and this is becoming more common in transport practice. Certainly it was never mentioned when I was a student or a graduate, whereas now it comes up a lot in local and national policy and planning. So in Kirikiriroa, for example, around 1 in 12 households has no access to a car. There are quite a lot of these households in Hillcrest around the university. People don't have a car for whatever reason. And then they tend to be concentrated in city centre, where you can get away without having a car if you don't want to for some reason, but also in places of higher deprivation where people cannot afford to have a car. And that is very problematic, because if you live in Enderley or in Seoul in Hamilton City, you don't have a car, there are not as many other options for you than if you live in the city centre. The buses are less frequent, the walking environment is not so attractive, it's not fun to bike through 5 crossroads, for example. So those people will tend to make fewer trips overall than other people would, and that has an impact on their well-being and on the economic productivity of the town. So we can look at that kind of data and map it to understand, well, what's the impact of different policies, where should we be putting buses, where should we be improving streets for people. If we're interested in well-being and how transport investment can affect that, we can also look at other ways to move people around. There is a whole branch of transport planning which is about companion driver services. There are 2 main kinds of those. One is a kind of premium taxi. There's a company called Driving Miss Daisy, for example, which costs a bit more than a taxi, but it's really a companion service where the driver will come and pick up the person right from their house or wherever they are. That might be somebody wanting to go to a medical appointment, it might be a disabled person, it might be a parent wanting to get their child taken somewhere with a trusted driver. They will come into the building and collect that person, and they're very friendly. Then they take them in the car and they take them right into the venue at the other end, whether that's the school classroom or the hospital, waiting room or clinic. There is also a version of transport called community transport, which is all around New Zealand, including in Hamilton. Cool. And that's run by volunteers. So volunteer drivers will do that exact same job as a Miss Daisy, but obviously their resources are more limited. They tend to be only for hospital and specialist medical trips run by the likes of St. John and groups like that. Some researchers in Scotland found that for $11 million invested in those services, the return is $2 billion to the government. So that's something that we could look to put into transport policy and appraisal. So as well as the monetised benefits, there are also the wellbeing benefits that people support. And this comes up quite a lot in transport, more so than other parts of civil engineering, where there are these anecdotal and qualitative bits of evidence that can be used to inform policy that we capture in different ways. So we're more likely to do than other types of civil engineering to do surveys with people, interviews, focus groups, to capture some of this information about why people make the decisions that they do and what the benefit is to them of having a certain transport option. I've been involved in a lot of those kinds of processes because I do a lot of work on transport and disability. So that has informed a lot of my career, done a lot of surveys of disabled people, and every part of New Zealand you'll have the same kinds of responses where people will say there are very steep gradients between the road and the footpath. So in this picture you can see what we call the curb cut. The curb runs around the corner to help drainage get to the drain and then there'll be a cut in that curb so that people who use a wheelchair or a child on a scooter or an adult on a scooter can actually get from the footpath to the road. Those curb cuts are supposed to be designed so that they're wheelchair friendly. That's our design user, because somebody using a manual wheelchair doesn't necessarily have the strength to negotiate a gap or a steep transition. This particular curb cut in the picture is not very well designed. It's too steep. It's also not angled across the road. So another group of people who use these curb cuts is blind people, people who have low vision, and they will orient themselves to cross the road based on the way that this curb cut is sending them. And this one is not sending them across the street, it's sending them out into the middle of the intersection. That is very common, and if you're walking around your community, you'll see very much an inconsistency in the quality of curb cuts. It's a very big problem that we've inherited from decades of not really understanding and enforcing these issues. I've also been involved on some walks, community street reviews, we call them, where local people will walk around to rate the streets in terms of how friendly they find it, and then that can be used to prioritise investment and improve footpaths, surfaces, new crossings, for example. If you get out and talk with people in community, it can be really impactful, and this quote is often in mind from one of the advocates that I worked with. We were out in Hamilton, actually, which is not where this picture is, but there was one of those chicanes on a shared use footpath, and it's very difficult for her as a manual wheelchair user to navigate that. She said, "Have you ever tried to negotiate a chicane uphill in a wheelchair? All of your weight has to shift, almost like you're skiing or snowboarding, from one side of your body to the other while you're pushing yourself uphill, and it can stop people from using that path completely, which means effectively they can't go where they wanted to go because they don't necessarily have the energy to divert a few hundred meters a different direction." The other way that we use data is for road safety, and we have transport engineers have access to the police crash database. Any road crash that's reported to the police ends up in this huge database. They have all sorts of information available about who was doing what. And often they have these written statements. I expect the police have converted to iPads and typing and stuff now, but there's a lot of handwritten reports in that system still. So they'll say things like what the driver said to the cop: "I was concentrating on keeping within my lane. I had bright sun in my eyes, became distracted, went through a red light at a pedestrian crossing." So individually, we can look at that particular site and see if there's anything to be done about that location. As a whole, across the country, we can analyse these kinds of crashes to understand trends and patterns. What causes crash risk? How can we design that out so that crashes are less likely? It's super important because there's a big social cost of road crashes. We hear a lot in the news about fatal crashes, whereas in terms of the cost to the country, fatal crashes are only about a third of that cost. There's a huge cost borne up in serious crashes, and how they work this out is pretty much just hospital data in terms of what it actually costs to look after and treat and rehabilitate someone who's been in a serious crash. There's also a cost of lost productivity of someone who's been in a serious crash and their career ends, or they're a child and they don't get the same outcomes in their life as they would have before. So economists work all that out. And actually serious crashes, as I say, have a higher overall burden than fatal ones, even though all we hear about in the news is the road toll, which is hovering in New Zealand between 300 and 400 people die every year, whereas serious crashes, which is where people are hospitalised from a crash but don't die, many thousands. We have many thousands of those, probably about a lot, dozens kind of every day. It's huge, and so road safety professionals are very passionate about addressing the causes of those and trying to do something better about it. The general philosophy around road safety engineering is a safe system approach where we don't blame a driver for making a mistake. We try to understand why that human person did what they did and how we can design a system where a mistake doesn't injure people seriously. So we put up with minor crashes because that's inevitable. We try and design out serious and fatal ones. That's the general philosophy on road safety at the moment. So there's a lot that we do and that we could do better in transport. So it's a really complex and interesting field. What can be done about it? So in practice, how can we get nice things? Here's a bit about Hamilton. This was Garden Place in 1963, beautiful paved paradise. Some people would like to see it return to that. I'm not one of them. As I've said, we have car-centric cities because they've been designed that way. What that means is most of us have a driving license as adults, and we have a car, and then we're kind of locked into that cycle as well, which means that people will push for more road space and more car parking because they think that would be good for them. But there's this big difference between what's good for me and what's good for the city, and it's very difficult to reverse that cycle. And it's not just a challenge of low density population. Here's a comparison from one of my favourite websites, which is called Two Maps, One Scale. So these two maps are at the same scale. They show Finland and New Zealand, Hamilton and Auckland. We have Te Huia, which is in its fourth year now of a 5-year trial, going twice a day to Auckland from Hamilton and back, whereas in Helsinki, which has fewer people than Auckland, they have 33 trains per day to a city which is half the size of Hamilton. Imagine that, 33 trains a day to Auckland. It would be a much easier option for all of us to just jump on a train on a whim to go there, especially when the City Rail link opens and we can pop out at Aotea Square, go to a show, meet people wherever around the Auckland train network. It would be game-changing. So just want to point out again the advantage of the transportation group. It's free to join. If you've got any questions about that or any of this, feel free to send me an email. I'm more than happy to connect you with the local branch. Come along to our events, which are usually catered. Sometimes they're even in pubs, just to meet people who work in transport in Hamilton in a variety of different roles and with different backgrounds, to find out more about it as your career goes on. And use LinkedIn as well if you want to. It's I have a love-hate relationship with it, but it is useful to follow people and organisations that interest you, learn more about the kinds of projects and opportunities that are out there, because there are still some, despite the kind of media doom and gloom about employment in New Zealand. There's a lot of good work going on in transport constantly, and it hasn't stopped. In terms of transport in New Zealand, we have these decisions made at every level, and transport is such a, I mean, engineering as a whole, I like it because it's so practical and applied and direct, especially with transport. We're out living it all the time. Everyone has an opinion on transport because it's part of everybody's daily life. But it's super interesting because of all the multidisciplinary opportunities to collaborate and understand, well, you know, its habits, its politics, and its engineering tradition, as well as potential for innovation to do some really cool and exciting stuff. If you learn nothing else, then hopefully you've learned that induced demand means more road space does not reduce congestion in the long term, and can be counterproductive for other policy objectives. We can use different data than we do now to help create that bigger picture. And it's important to consider who is benefiting from this investment and to go and measure that to find out what do people need to live good lives, how can transport help them. There are some links here, including that second one is about my PhD thesis, which was about distracted driving, specifically daydreaming during driving. That's just a 10-minute radio interview that I did about that if you're interested. And there's one of my favorite journal articles, or it's, journal articles about the myths of autonomous vehicles and why I haven't talked about them as the savior of the human race. So thank you very much. I do encourage you to email me if you have questions or want to talk more about transportation engineering.